dealing with multivalent. So multi is a prefix you're familiar with. It means many. Valent refers to charge. Okay? There are many metals in here that have multiple possible charges. In grade 11 AP chemistry, we dive into sort of why some of these metals have different charges. Regular Chem 20 and 30, you never get a why. But in the AP version, we'll dive into why iron, for instance, can have several charges. Something like copper can be +1 or +2, nickel can be +1 or +2. And in your data sheet, you have the most common charges. You don't have every charge possible on your data sheet. Okay. So don't be shocked. Someday you might be doing homework and maybe you're doing cadmium and it has a question with a different charge in it. These are the only ones you're expected to know. So don't worry about memorizing the other charges, okay? But these are the most common, and often there is no other charge possible, but every now and then there's a very uncommon charge. Okay? Just don't let that bother you. Don't worry about it. Just don't freak out when you go, that Mr. Curtis is a liar. He said that was the only charge possible and I saw something else, okay? These are the most common. These are the only ones you have to worry about knowing. Okay, so we're only focused in on these and maybe the odd one of those. Okay. Does anybody remember, did they learn last year what you do to tell the reader what charge this has? Has anybody come across that? Yeah. Perfect. We're going to use Roman numerals to tell the reader what charge of the many possible charges it is. If you've never heard of that before, don't worry. I'm going to be going through it. Okay. So many of the transition metals, which in AP chemistry, we're going to call the D block next year. Don't worry about D block this year. I'm just trying to get you used to some of the Chem 20 lingo that I'm going to use. Okay. Can have multiple possible charges. Okay. When a metal has multiple charges possible and it's in an ionic compound, you need to tell the reader which one it is. Okay? You don't have to do this with sodium because it can only be +1. Okay? You're wrong. You cannot use a Roman numeral with sodium chloride. Okay? You will not get full marks. You cannot put Roman numerals in all the questions. Okay? But when there is multiple options, as per your data sheet, you put in a Roman numeral to denote the charge. We're going to go through some examples. We're going to do some chemistry in a second, but we should probably do some Roman numerals first. Okay? Hopefully some of you are familiar with Roman numerals, others may not be. I'll let everybody get caught up with writing and then we'll start at 1. So what is the Roman numeral for 1? I. What is number 2 if you're a Roman? 2 I's. Number 3, 3 I's. Seems pretty simple. 4 I's? No, 4 is 1 before 5 is how the Romans did it. So I'm going to skip 4. 5 is a V. Okay. Their way of doing 4 is saying 4 is actually 1 before 5. So IV, 1 preceding V, 1 preceding 5 is 4. So 1, 2, 3, 1 before 5, 5, 6 is 1 after 5. 7 is 2 after 5. Then it keeps going. Eventually there's a digit for 10, and they have certain shapes that represent certain numbers, and you're either going something before or something after that number. But we don't need to keep going for the sake of this course. 1, 2, 3, 4, 5, 6, 7 should be more than sufficient to get us through. You'll largely be using the first 4. Okay? So you need to understand that bit of Roman numerals for this course. Okay? So my first example, FeCl2, I don't want to say the name quite yet. Okay. So Fe is iron. Write it exactly like normal. Cl is chlorine as an atom turned into chloride. Okay. And then you've got to do a little check. Okay. I suggest you do it in this order. Name the metal, deal with the anion, change that ending to "ide," and then go and double check that metal. Does Fe have more than one charge option? It does, of course, that's what I'm teaching right now. But on a test or quiz, they'll be all mixed up. And you got to identify which ones you needed and which ones you don't. Okay, we need to figure out which charge it is now. What are our 2 options? +3 and +2. We've got to figure it out from the fact that there's 2 chlorides and only 1 iron. Okay? The charge of chlorine we know. Okay? What is Cl when it has a charge? It's only one option. -1. Okay? But there's 2 of them. So in total, we've got -2 in total. Okay? We've got 1 iron, and that's got to balance out the -2. So this must be the +2 version. Okay? If it was the +3, our charges wouldn't balance. Okay? So we've got a fair bit more work to name these. We've got to figure out the possible charges. You've got to see if there's multiple options and then figure out which one it is. So this is iron. We're going to put brackets because we have to denote which type it is, and we're going to put the Roman numeral for 2 in between. So the proper name is iron 2 chloride. Okay. I've got iron again, and we know it's +2 or +3. Yes, you need to put in the brackets. So we've got iron. We know there's multiple options, so I'll stick the brackets in right away. We've got nitrogen as the atom, but this is the ion, so we switch it to IDE. Nitride, and now we've got to figure out which type. Okay. We got 1 of each ion, so that makes our life a little easier. What is the charge of nitride? -3. So this must be the +3 option to balance out the charge. The +2 wouldn't make this a neutral formula unit. So this one is iron 3 nitride. Okay. You must have that Roman numeral for it to be correct. Okay. This one I put in just to kind of, it looked weird, so I put it in. Anytime a letter is little, it goes with the preceding symbol. So this is big C, which you might think is carbon, but then there's a little O after it. So it's not carbon, it's whatever CO is, which is cobalt. Okay. Then we're back to a capital letter all by itself, which is O for oxygen. Okay. Now it's in an ionic compound, so it's oxide, the ionic form. Does cobalt have more than one charge? Yeah, so we've got a couple options. We don't even care what the options are because we're going to have to figure it out anyway. Oxygen is 2-. There's one of those. There's only one cobalt, so this must be the 2+ option. So this is cobalt 2 oxide. How many would like me to do a couple more examples? I've got a whole bunch left. I could do a couple more if there's requests. Like a couple more? Okay. So we've got cobalt again. We've got that big C, that little O, and then we've got a big C and then a little L. Okay. And occasionally this causes confusion. A student isn't sure whether this is cobalt, carbon, and iodine, but that's a little L. So smart, just, I wish I could change the font, but I can't. So, but that's a CL. So we have cobalt. We know cobalt has multiple charges, so we have to use the Roman numerals. Okay. A lot of books call this the stock system. So if you're doing homework, you're doing a workbook and it says use the stock system, that's using Roman numerals when something is multivalent. Okay. And we have a chloride ion. Chloride is always 1 minus. It's group 7. So when it's charged, it's -1. There's 3 of them. So that's going to be a total of -3. We've got 1 cobalt, so it must be the +3 version. I'll do 1 more, and then there's 4 or 5 left for you to work on. Switch to copper. Okay. Now, copper, there's 2 forms. The +2 is really easy to pick out in solution. It's a beautiful blue, where the +1 for copper is a greeny blue, a very different color. Most ions are clear. If you actually collect ocean water, it's clear. Okay? The ocean looks blue because the sun bounces off the ocean. But if you actually pick up ocean water and just look at it in a beaker, it's clear. Most ions are clear, but copper 2+ is a blue, but we're not sure which one that is yet, the +1 or the +2. So copper, something, bromide. Okay. We have another group 7 atom, a halogen. That's 1 minus. There's 2 of them, so that's -2 in total. So this is the copper 2+, that nice blue color version of copper. So the proper name is copper 2 bromide. Okay. So I'll give you a few minutes to practice these last 4, and then we'll roll into polyatomic.